Hi everyone, my name is Maya Tattenklow. I work as a senior project engineer at RK&K here in Baltimore. We're a civil engineering consulting firm. I work entirely um, on wastewater treatment design, studies, reports, rehabilitation, all that kind of stuff. A little bit about me and how I got here. I actually studied environmental science in undergrad, and then I did the Peace Corps, and I learned all about the importance of having clean drinking water and good sanitation and waterborne diseases. When I came back, I worked for EPA for a little while in DC, and then I decided to go to grad school for engineering. Um, that's what landed me at Maryland, and Alba, or Dr. Torrance, was my advisor. I did my master's research in microbial fuel cells, so basically um, harnessing the energy generated by certain microbes during their breakdown of organic matter in wastewater treatment. From there, I landed a job for Baltimore City at Back River Wastewater Treatment Plant. That's where I am right now today. It's the largest wastewater treatment plant in Maryland, and the flow averages, the design flow is 180 million gallons per day. It averages about 130. When I worked here at Back River, I was in charge of running the sludge thickening and digestion process. So really my research for Dr. Torrance and at Maryland was about harnessing energy from wastewater, and that's something that municipalities do every day conventionally through anaerobic digestion. So the lab that we're going to talk about, or that you're going to work on, has to do with anaerobic digestion at Back River. So Back River has two egg-shaped digesters, which I'll show you here in just a minute. They're each 3 million gallons, and then it has additional upstream thickening processes and downstream polishing, digestion, and dewatering. So if you just hang tight, I'll show you a little more about that. So just a quick run through of the plant. Basically, the sludge thickening and digestion processes accepts the sludge from throughout the plant. So here you can see some large round tanks just past that blue water tower. Those are primary clarifiers, and that's where you'll get your primary sludge from. And then if you see those long kind of rectangular tanks, and there's a lot of them, those are the secondary reactors. So that's your activated sludge process. Behind there, you can't really see it, but there's additional clarifiers, secondary clarifiers, that give you the secondary sludge or waste activated sludge. So all of those sludges are combined. They come off of the clarifiers pretty thin, usually less than 1%, and then they have to be thickened up to 5 to 6% before they can be fed to the digesters. So at Back River, they actually do that through a variety of processes. There's gravity sludge thickening, gravity belt thickening, and dissolved air flotation. Once everything is thickened, they're combined into a sludge blending tank or holding tank, and then pumped over here to the digesters. I'm actually standing on top of the acid phase digester, which is a first phase of two-phase digestion. And here you can see some of the sludge piping and the steam injectors that actually heat up the sludge before it, or as it recirculates in this tank, and before it's fed over to the egg-shaped digesters. Here's a view of one of the egg-shaped digesters at Back River. They're famously known as the golden eggs, as you can see from the golden cladding. They can be seen from the Baltimore Beltway from 695. And there's two of them, so there's one. The other one is here. They each hold 3 million gallons of sludge. And basically what happens is the sludge is anaerobically digested by anaerobic bacteria, and in their breakdown and consumption of organic matter, they actually produce methane gas, and the methane gas is harnessed by the plant and utilized in various ways. It's utilized for heating plant buildings, for heating the digesters themselves. These bugs are like us, they like a warm 98 degrees to do their metabolic processes. The gas is also used in chillers throughout the plant, and at a cogeneration facility where they actually burn the gas or use the gas as fuel in generators and produce electricity that is fed back to the grid. So for this lab, I've provided some real data from Back River that was taken when I worked here and since. This is the sludge data that the operators collect every day. They take samples every day, and they're important parameters that we use to monitor the process. So one of the key ways that you both monitor anaerobic digestion and that you report that you're getting your Class B biosolids at the end is through volatile solids destruction. And that's a measure. You have to have your total solids and your volatile solids of sludge coming in and sludge coming out in order to determine that, that value. That's also a good indicator of expected gas production, though we meter all the gas that's produced here. The other factors that you'll see in the data are volatile acids and alkalinity and pH. And those are also important in just looking at the health of your system and the health of the process. And they can be a good warning sign if you're going to have any sort of digester upset. Remember, it's a biological system. It is a digester, just like we have digesters. We can have upsets, too much acidity, that's a problem, temperature changes, things like that. So these are all like real data that I used to monitor it. Now that I work for RK&K, I'm consulting for the city of Baltimore, and we're actually doing a renovation of the egg-shaped digesters, which should be under construction here in the next couple of years. Thanks everybody, hope you enjoyed the lab.